Science, and we're going to focus on alpha and beta decay. Let's start with alpha decay. In alpha decay, a nucleus gives off an alpha particle. An alpha particle is 2 protons and 2 neutrons. The general equation for alpha decay is quite simple. The parent nucleus goes to the daughter nucleus, giving off the alpha particle. The parent nucleus refers to the original unstable nucleus, and the daughter nucleus refers to the nucleus that's left after the radioactive decay. The alpha particle is represented either with the Greek letter alpha or with He. The He obviously represents helium, and that's because an alpha particle is the same composition as a helium nucleus. Let's take a look at an example. Radon-219 decays into polonium-215. Radon we represent with Ra, polonium is Po. And of course then we have to have our alpha particle, which I could draw as an alpha or as a helium nucleus. We need to make sure that the mass numbers balance. We've just said that it's radon-219. There it is. And the helium nucleus, or the alpha particle, has 2 protons and 2 neutrons, so it has to have a mass of 4. Making this balance, we can see the polonium must have a mass of 215, because 215 plus 4 is 219. Likewise, when we look at the atomic numbers, radon, which has the atomic number 86, decays to polonium, and helium, which has, or the helium nucleus, or the alpha particle, which has 2 protons in it. This you need to learn. However you want to write it, it must have a mass of 4 and a proton number or atomic number of 2. To balance this equation, we need 84 here, because 84 add 2 gives us the 86. Now let's look at beta decay. Beta decay occurs in a nucleus when a neutron decays into a proton. The proton is positively charged, so to conserve charge we have to give off an electron, and that electron becomes the beta particle. The beta particle flies out of the nucleus because that's not where electrons belong. So the general equation looks like this. The parent nucleus decays into the daughter nucleus and a beta particle, a high energy electron. We can write it as either the Greek letter beta or as an electron. Let's look at an example. Carbon-14 decays to nitrogen by beta decay. So if I've got carbon, and that decays to nitrogen plus a beta particle, I'm going to write it as an electron. Let's have a look at the mass numbers. I've just said it was carbon-14. The mass of an electron is tiny compared with the mass of a proton or a neutron, so it has a mass of 0. So what must the mass of the nitrogen be? Well, it must be 14 as well. So 14 add 0 gives us 14. Let's look at the atomic numbers. The atomic number of carbon is 6. Now, we write down here -1. That's one of the ways you can represent an electron or a beta particle. Now, to make both sides of the equations balance, we need something -1 to give 6, so the answer is 7. So therefore 7 minus 1 is 6. Now sometimes you don't know what the products are, but you can work out the numbers. All you have to do then is look on the periodic table to see what has an atomic number of 7 or what has an atomic number of 84, and you'll find it's nitrogen or polonium. There's no substitute for practice. You'll find in the description below a link to some practice questions and answers on my website. To help support the channel, please like, subscribe and comment, and watch this.